Hi everyone, and welcome. We'll begin in just a moment. Just a quick note, this is a live closed session, so feel free to drop your questions and comments in the chat as we go. We'll address them after the session. Before we dive in, here's how today's webinar is going to unfold. We'll start with the generational shift in technology, because the way children interact with tech today is fundamentally different. From there, we'll look at why AI is no longer optional. It's becoming the baseline. Then we move into something critical, skills that outlast tools, because tools will change, but the thinking stays. We'll talk about when children learn best and why certain age windows matter more than most people realize. Then we break down how real tech thinking is built, from logic to problem solving. We'll also explore AI as a thinking partner, not just a tool that your child uses. From there, we'll get practical, with what you can do at home with your child starting today. And finally, we bring it all together with what effective learning actually looks like and how to recognize it. By the end, you'll have a clear lens on not just what your child should learn, but how they should learn it. Now, to take us through this journey, we're joined by an industry expert who works with students every day and sees the AI shift firsthand. Please introduce yourself.
Hi everyone, my name is Prerna Kaushik. I'm director here at iCode Murphy. I've been working with iCode for almost a couple of months now, and I have had an opportunity to deal with kids of all the age groups, starting from age of 3 up till the age of 18. And one thing that I have noticed, which is common in kids of all the age group, is the confidence and the interest that they build when they learn things the right way. And I say that because, for example, like if I'm trying to teach a kid to, say, solve a puzzle, and I go ahead and hand them over a puzzle of, saying, 500 pieces, I'm pretty sure by the end of it, either they would think that it is not something that intrigues them, it is not something they want to do again, or if they're not able to do it, they're going to think that, oh, this is not achievable. Right? But for example, now I go ahead and hand them over a puzzle with, say, 50 pieces. So by the end of the day, when they finish it, they're going to think, oh, this was achievable. This is something I like. This is something I would love to do again. And that basically spikes their interest and confidence. It is pretty much the same. So when they learn the things right way, from basics, from fundamentals, brick by brick, their interest and confidence gets a boost, where they are more intrigued, they want to learn more, they want to learn it the right way. So I would say teaching them the fundamentals from the base the right way matters a lot, no matter what age group they are in, what they're trying to learn, be it like technology or even any life skill. That is how it should be. That's what I personally think.
Let's start with the biggest question most parents are asking right now. What does it actually mean to prepare a child for an AI-driven world?
So when parents say these kinds of things, they usually mean that they do not want their child to be left behind. They picture a future filled with AI tools, automation, coding, and then jobs changing rapidly, and they want their child to be in clear advantage. That instinct is absolutely right. Where I think most of the parents get it slightly wrong is assuming that preparation means chasing the newest platforms or the newest app or the newest programming language in the industry. But in reality, tools will keep on changing. That is how it has been for I don't know how many decades, and that is how it's going to be in the future. What lasts much longer are their fundamental skills, right? Their logical thinking, problem solving, creativity, communication, or even the basics of all of that, their confidence to learn new systems quickly. A child who understands how to break down a problem or like test the ideas that they have in their mind or recognize patterns and can think critically about these kind of situations can learn almost any tool in matter of weeks, I would say. But without these foundations, even the most advanced, or let me say most basic AI tool can feel overwhelming or confusing. This matters because the future of work is shifting fast, right? According to the World Economic Forum, 65% of children entering primary school today might end up with a job that is not even in the market yet. So we are basically preparing them for the jobs that are still being invented. At the same time, industries that are embracing AI are seeing much higher productivity growth. So this is not only about becoming a software engineer, it is also about becoming effective in your job. I would say yes, the AI will replace some of the routine tasks, but it is also expected to create millions of new opportunities, especially in technology or data or like economy. So the real goal is to teach your kids not to compete with AI, but to use it for their advantage, to adapt to it, and to work alongside it with confidence.
Over the last few years, what's one clear shift you've noticed in how children interact with technology compared to earlier generations?
One clear shift that I have noticed is that children are interacting with technology much more earlier and naturally than any of the other or earlier generations ever did. For many kids today, technology is not something that they're going to learn later in life, right? It is already a part of how do they play, ask, or like explore their surroundings or like solve problems. Even more basic than that. Like, for example, imagine a kid listening to their parents saying, "Hey Alexa, play song," right? That's their exposure to technology. That's their interaction with technology. What is especially striking now is that how early AI is entering their world as well. Nearly 30% of children of age group 0 to 8 have already used an AI or have at least had an interaction with AI in one form or another, which is quite striking because initially these kind of platforms were made for kids of 13 and older, right? That tells us something important, which is that children nowadays are not waiting for the future of technology. They're already living in it. They're already growing up inside it. The second major shift, which I feel that I have noticed, is the expectation. So kids nowadays want instant feedback, right? They go ahead, ask the question, tap, click, enter, and they have the answer, like an immediate response. Because of that, they engage more deeply in environments that feel interactive, responsive, and dynamic, I would say. When learning is designed through, say, games or like stimulation or like any of the hands-on digital experience, engagement rises dramatically because it matches their natural instinct of experiencing the world, right? That is also where traditional classrooms sometimes struggles, I think. Many learning environments still rely on, say, delayed feedbacks, or I would say passive instructions. But today's children are more motivated when they can experiment, get a result, try on like thousands of ideas going in their mind right away. So the biggest shift is not just the screen time anymore. It is that children nowadays expect technology to be more interactive, to be more intelligent and responsive, and that is basically reshaping how they learn. That is how kids want to learn in today's age, and rightfully so. I think when they get to interact or like have intelligent responses from the source, that intrigues their inner capability of learning things.
How has AI changed from a luxury to a baseline necessity? And why could traditional schooling fall behind?
One of the biggest shift that we are seeing is that AI is no longer a luxury skill. It is becoming a baseline necessity, right? In many ways, AI today is what you can say computers were in 1990s, which were once seen as like optional or like a luxury, is now absolutely impossible to ignore. Microsoft's 2025 education report found that 76% of global education leaders think that AI literacy is kind of an, you can say, mandatory thing for every student nowadays. And also, it is widely accepted by students as well. A recent higher education survey found that 92% of students approximately use AI for their studies, their projects, and their overall growth, right? Which is incredible. The concern is that students are already using these tools, like to do possibly everything in their day-to-day life, right? but they are doing so without enough structure or like context or like guidance around this. Jobs for the Future reported this week that learners are still more likely to learn about AI from, you can say, like friends or like family or like social media discussions or like general gathering discussions instead of learning things about AI from like a school or like a training provider. These kind of scenarios create real guidance gap, I would say. Students may know how to get an answer from AI. We all did that with Google pretty much all our life, right? But not how to like frame those questions to get the answers that they are actually looking for, and to figure out the answers that they are receiving is like what they were actually looking for, to figure out it's not just an AI hallucination thing happening, right? That is where traditional schooling may be falling a little bit behind. Many schools are still teaching as if AI is like a add-on on top of their actual skills, right? But students are already living in a world, we can say, which is enabled by AI. The goal now is not to just access AI, but it is to teach your students, to teach your kids to how to navigate through AI world, right? How to use it wisely, how to use it ethically, to be pretty honest, and how to use it more creatively. Like, not just go in there, ask a question, pick up the first answer you get, right? But to frame a question in such a way that it uses all the information that AI has optimally and give you the best answer possible out there.
In the workplace, technical tools change constantly. So what skills actually matter long term?
When we look at future of work, the biggest mistake is to focus too much on like one tool or one language or you can say one AI platform. Those will keep on changing. That is how it has been in past. That is how it's going to be in future, right? What matters more are the foundational and like you can say basic skills for kids that are going to help children adapt to no matter what comes next in future. One of the most important of those skills is pattern recognition. When children learn to see patterns in data, behavior, logic, and they are not just you can say memorizing steps, they are learning how the systems work, right? That gives them the ability to understand new technologies much more faster instead of feeling like they are starting over every single time something new shows up in the industry, right? Along with that, critical thinking, problem solving, communication, and creativity are essential skills as well. AI, I would say, can generate answers for you, right? It might be quick as compared to what you would do without AI. But children still need to ask the right question, right prompt, evaluate what is accurate, and decide what to do with the information that they are receiving, right? And to be more honest, like also should be able to judge that the answer that they are receiving, is it right or not, right? So the goal is not simply to teach kids how to use today's tool, right? It is to build thinkers who can confidently learn whatever tool shows up tomorrow. We want them to be more effective and more critical when they look at the answers thrown away by AI, not to be just blindly following whatever they get.
Is there a specific developmental stage when understanding how technology works has the greatest impact?
The age range of about 8 to 14 is a critical window because this is when children begin moving from simple use of technology to actually understanding how it works. At this age, they are better able to think abstractly, follow logic, recognize patterns, and connect actions with outcomes and not just like blindly follow the instructions. That makes it the ideal time to introduce concepts like, you can say, sequencing or like problem solving, or even like how basic digital tools make decisions, basically critical system thinkings, right? But the earlier foundation matters too, don't get me wrong there. Between ages 6 to 8, children build familiarity, confidence, and curiosity in those concepts. They may not be ready yet to think deeper or like understand deeper technical concepts, but they are ready to explore instructions. They are ready to basically get intrigued by those instructions. And to understand what are the causes, what are the effects, and the structured thinking behind it, be it like games or like puzzles or like any guided activity as well. So by the time that they reach 8, which is the window that we are talking about, which is 8 to 14, they are not at the starting point, or like they are not starting from zero, to be pretty honest. They already have a comfort with technology, they know what they're looking for, they are already intrigued by it, and a basic mental framework for how it behaves. The combination of early exposure and later reasoning ability is what makes the period so powerful for them for building true, you can say, technological understanding towards the concept.
How do skills like logical sequencing, debugging, and understanding systems prepare children to adapt to any new technology?
I would say skills like logical sequencing, debugging, and understanding systems give children something much more valuable than knowledge of any one tool or like one technology. They give them a framework for learning, right? Like a base, or like you can say a solid foundation to stand on. Once kids understand that every technology has like few of the basic concepts like inputs and processes and then outputs, on basis of that, new tools stop feeling random or intimidating, or you can say like completely new to them. They begin to see that even if the interface looks different, or like few syntax here and there look different, the logic beneath them, the understanding of the code beneath them is often very similar. Logical sequencing teaches them on how to break a problem into steps and think it in a more, you can say, organized way, right? That helps them with everything from coding to using AI tools effectively. Understanding systems helps them to see how different parts connect to make a system, why something happens, or like where to look when something out of the blue happens or something goes wrong, right? Debugging may be one of the most important lessons of all. I would say that debugging is one of the most important aspects of it. It teaches them to navigate through the code that's already written, right? It teaches kids that mistakes are not failures, but they are basically the hidden information. A wrong result is not the end, or it might be like a correct result for one and a wrong result for another is not a mistake, it's not a failure, but it's a clue, right? The mindset builds resilience, patience, curiosity, diversity of understanding that how a single program can work, or can process different inputs very differently to give you different outputs, right? In an AI-driven world where tools evolve constantly and iteration is a part of everyday work, that way of thinking is essential. It basically is like basic blocks for them. Children who can test, or you can say adjust and improve, will be far more adaptable to new technologies, new tools than those who know how to just follow a fixed instruction, or just know how to follow a step of instructions for one single platform.
How does AI change the way we should look at problem solving? Why is prompt engineering and computational thinking being considered the new literacy?
AI changes problem solving because the hardest part now is not just finding the answer, but the hardest part is framing the right question, asking the right question, writing the right prompt to get the appropriate data and answer that you need, right? That is why computational thinking matters so much in today's world. It teaches children to break a problem into parts, identify patterns, decide what information matters, and build a clear process and data out of all the data or all the information that is being sent out. In an AI world, weak thinking produces weak outputs, you can say, while strong thinking produces far more useful, strong, and related results, right? Employers are already rewarding that difference because that makes a huge difference in the productivity and to the point answers that they need. Prompt engineering is already becoming a huge hype. There are courses, technical knowledge, even colleges offering specific courses designed around prompt engineering, right? Which is basically asking well, giving context, setting constraints, and refining your output result or like your output data until you get your actual output, to be pretty honest. This is not separate from thinking, if you think about it. It's more like an applied thinking. And the future of work will not reward, I would say, technical knowledge, but it would reward your technical knowledge backed up by an applied thinking. This is why children, I would say, need both critical thinking and technical fluency and human judgment. Like, I would say AI can help you, but it would never overshadow your human judgment. Even leading AI researchers, like, if I'm not wrong, the name is Dennis, argue that learning how to learn may be the most essential skill for the next generation. In the end, the new literacy is not just using AI, but it is thinking clearly, questioning AI wisely, and adapting constantly, and also figuring out the difference between an AI science data-backed answer and an AI hallucination.
What's one tangible thing that the parents watching at home can do tonight to move their child from being a passive user of tech to an active explorer?
One simple thing that I can think of that parents can do is maybe they can ask their kid to teach them or explain them their favorite game or like their favorite app that they use so much on daily basis. That small shift changes their kids' role from like being on the receiving end to basically being on the giving end, right? Instead of just consuming technology or like consuming games or apps, now they start explaining it. So when they start explaining it, they start thinking through it, right? Now they have questions popping up in their head, noticing minor details that they might have not looked at or have noticed if they were at a receiving end, right? It's pretty much simple as like when you ask somebody to explain you a calculation, right? There might be a very minor thing that they might have not noticed when they were doing it by themselves, but once they start explaining it to you, they'll be like, oh yeah, now I understand how this works. That's a very common thing. It's a very humanly thing, right? As they walk you through it, what you can do is ask them follow-up questions that basically forces them or like that basically makes them question their knowledge about it. Like, for example, what happens first? Why do you think it gives you the result? Or what do you do if something goes wrong? How does it know what you want? Those questions help children move from just like being on the receiving end to giving end. Now they want to understand the tool. Now they want to understand the game that they are explaining to you, right? You do not need to be a tech expert. I would say it's better if you're not a tech expert. In fact, it is better if you stay curious. The goal is not to test them or like, I would say test their knowledge about the app or the game. The goal of this conversation is to make them reflect on it, right? To make them understand things, to make them think that, oh, everything has a deeper meaning and we need to find it. That reflection builds problem solving, communication, and confidence in them. The first step towards becoming an active explorer or like active thinker, I would say, is very often just learning to explain how things work technically, right? And that also creates a curiosity in them that, oh, this is my favorite thing, but I need to know how does that work. That would be a great exercise that they can do at home.
Based on everything we've discussed, like thinking skills, progression, and adaptability, what does an effective learning model for children actually look like?
I would say an effective learning model for kids should be in a clear progression, which is basically, let's say, like play, logic, creation, and reflection, right? Kids learn best when they get to explore with their curiosity and then begin to understand patterns and rules and then build something of their own. And then finally go back to what they built and like have a reflection on that to see, oh, this worked for us, oh, this did not, I could have done this better, this could have worked better for us, and those kind of scenarios, right? I would say each stage is kind of built on the one previous to it. Like, for example, play creates a comfort for them. And then you have logic that adds structure to that comfort and play. Going forward, then you turn those ideas into action, which is your creation stage, and those actions are basically built upon the logic, right? And then in the last, you have reflection that develops judgment. So, which basically means that you are reflecting on your creation you did in a step before, right? That kind of progression matters even more in an AI based era, I would say, because success is not just like coding. So, research and workforce framework increasingly talk about four broad spectrum areas for kids, which is their cognitive skills, their interpersonal skills, their self-leadership, I would say, and also their digital fluency. And they all, all four of these are equally very important. So in other words, I would say kids need to think well, they need to work well with others, they need to manage well themselves, and also understand the technology at the same time, which basically creates a plan and also a balanced flow for them.
And how does the iCode curriculum specifically prepare a student for this?
I would say iCode curriculum prepares students by moving them from simply consuming technology to actually creating with it. And that shift is very powerful, to be honest. When a kid goes from playing a game to building one, they stop seeing technology as some magic happening on the screen, right? Or behind the screen. They start understanding the logic behind it. They start connecting to the logic behind it. What makes iCode especially effective is that much of this happens through very steady learning, right? Kids feel like they are playing, exploring, and creating, and not sitting in a hour-long lecture, to be pretty honest. But underneath that experience, they are constantly building real skills like sequencing, problem solving, debugging, pattern recognition, or logical thinking. That matters because these are the same foundational skills that help kids understand new technologies, AI, data, or even future technologies that we don't even know about yet. So iCode is not just teaching kids to, you can say, write a code or use a tech. It is helping them act and think like creators, like problem solvers, or you can say what we call in traditional language as engineer mind, where they think and try to understand deeply behind everything that's happening around. And that is incredible, to be pretty honest.
If a parent wants to see if their child has a natural spark for this, what does the first free experience look like at iCode?
At iCode, the first free experience feels less like a trial class and more like a glimpse into what their kids' future learning environment would be like. The classroom is energetic, structured, and intentionally hands-on. It's more like a safe space where they show up, they are encouraged to explore, test their ideas, make mistakes, and then try again without feeling awkward about it. What parents often notice right away is that instructors do not simply lecture the kids, or they are just not simply presented the class, but they are actually guiding them through the process. They ask thoughtful questions, spark curiosity among the kids, and adjust to how each kid learns and thinks around the ideas. That makes the experience feel more personal and more supportive and engaging towards the kids. Kids also get to learn algorithms and other basic skills related to the belts that they are trying, right? Which sparks more curiosity of the interests that they already have. Kids also get to learn alongside with other curious and motivated kids who are excited to build and create. And so many times they just make friends who are like-minded, right? Collaboration happens naturally. It's like they just meet the kids with same interests, trying to learn same things, and they spark the collaboration. They share ideas, help each other, let's say debug, and then celebrate the process together or build something out of something together. It's not like a one-person process, but it's more like a group process. So that first free experience or first trial class experience is really about discovering whether your kid actually lights up when they enter the environment, given the chance to create, solve, and explore with the technology, and to see how comfortable they feel with kids who are trying to do and learn things similar to them. Because honestly, the best way to understand is to see it, is to experience it, to walk into a classroom, feel the energy, watch the kids explore, build, ask questions, solve problems, and create things that they are genuinely proud of, and things that we are proud of that they have created out of their ideas, and to see what so much interest and curiosity looks like in real life. That is when it really clicks for you, for us, and for the kids. And if there is one message that I want parents to take away today, is that focus on foundations over trends. I said it before and I'm going to say it again, that trends change every 2 years. That is how it has been in past. That is how it's going to be in future. The newest app right now, it's going to change. The hottest trend right now will not be surviving next 2 years. The technology that everyone is talking about today might not even be in picture 10 years down the line, right? But their curiosity, their confidence, their creativity, their logic, and their communication skills, those skills stay valuable no matter what the future looks like, no matter it's 20 years down the lane or like 40 years down the lane. These kinds of skills are going to be embedded into them. And that is why at iCode, we are not here to overwhelm kids with the information. We are here to inspire them. We want them to explore. We want them to explore their own mind. We want them to build. We want them to ask questions, test their ideas, make mistakes, make blunders, try again, realize what technology is, and not just something that they can consume, but it is something that they can create with, they can build around, they can play around with, right? And to the parents listening, yes, your concerns are valid. This is the fast moving, tech heavy world. And of course, you want your kid to be ready, right? But readiness does not have to start with, you can say, fear of change. It can start with curiosity. It can start with one experience, one class, one spark, or like just one basic fundamental foundation skill that we are trying to build in the kids here. And I'll say this proudly, very proudly, our kids do amazing things. So many times I look at things created by 5-year-old or 7-year-old and I'm amazed. I'm like, I don't know how they did it. I don't know how they thought about it. It's amazing. It's incredible to look at things that they do, the projects that they build, the confidence that they grow in, the way they talk about the things that they are doing, the way they describe their ideas, the way they describe their projects. It's incredible. The way they surprise even themselves. Like, I would say parents are surprised at what they're doing here. It is incredible to watch. Let us show you the environment, the learning, and the amazing things the kids are capable of. Sometimes I would say all it takes is a slight mini spark to start something truly special. I can also say that these kind of environments force them and basically push them to be motivated, to think and look at everything with an eye of curiosity, and that is what we are here for. I'm looking forward to see you all here. Thank you. Have a great day.
Thank you so much for these insights, Purna. And thank you to all the parents who have taken the time to be here today. If you have more questions or topics you'd like us to cover, drop them in the chat and we'll get back to you. Or feel free to connect with an expert at your nearest iCode center anytime. We look forward to keeping this conversation going. See you next time!